Yeah, so I do my mid-math with Design Ever Have. I think it's the simplest way, and it's really the only way that really clicked for me. So I'm gonna go ahead and switch the camera, and I'll go over this PowerPoint that I put together. So, can you see me? Or can you hear me? Yes. Okay. So it is, your order is what you desire. So this is what you want to give your patient. And then your have is what's available, what's in your dispensary. And this is mainly, so for if you have a problem and it's, your patient has an order of Benadryl of 50 milligrams, and what you have available is 25 milligrams, all you do is 50 divided by 25, which is 2. So if these are pills, you would only give 2 pills. Okay. And then for next, so that's for mass, this is mass for liquid. And so it's the same thing, it's what you desire over what you have, but you want to add times the volume. It's blurry, that's weird. Is it? Yeah, just keep going, I'm gonna go grab him. So for an example, if you have furosemide ordered at 40 milligrams divided by 10 milligrams available by 5 mLs, this is what you would do. So you would do 40 divided by 10 times 5, which essentially would be 20 mLs is what you would give your patient. Let me see. I'm also going to give some practice problems at the end. This is just kind of go with the flow. Another one is volume for time. So the formula is the volume of what you're going to give to your patient over the amount in hours will give you your flow rate. So for an example, if I'm your patient and I need 500 mLs of normal saline and you have 120 minutes to do it, you want to convert this to hours. So instead of 120 minutes, that is 2 hours. So essentially it'll be 500 mLs divided by 2, which then your pump rate would be 250 mLs per hour you would give this patient. We'll give another example problem. So if you have 600 mLs of fluid that you need to give your patient, and you have only 4 hours to do it, it's essentially 600 divided by 4, which equals 150 mLs per hour, is what you would set your IV pump at. Let me see. Another problem that you'll get on the med math exam that is kind of tricky, and it took me a while to figure it out, is your GTTs per min. So this is the amount of drops your patient is receiving. So the formula would be your volume that you desire and then your time in minutes times your drop factor. And your drop factor, it'll be given to you in the problem. And what that means is it's the type of tubing that you'll be getting for your IV. So this problem, you have 450 mLs of fluid to give within 2 hours, but for this formula, you want to give it within minutes. So it's 120 minutes times 10. So we'll say the drop factor is 10. So you do 450 divided by 120 times 10, which should give you 37.5. But for here, it's impossible for you to give half a drop. So then you would actually just round to 38 GTTs per min. I'll do another practice problem. So another problem is calculate GTTs per min if your patient needs 200 mLs over 1.5 hours with a drop factor of 15. So you have your 200 mLs, you want to convert this to minutes, which is 90 minutes. So now what you have is 200 mLs of fluid to be given within 90 minutes times 15, which is the drop factor, which you would then get 33.3. But in this situation, you can't give a little bit of you can only give whole numbers of drops. So instead, you would just drop this, and you would only be giving 33 GTTs a minute. And then lastly, especially for your peds patients, you would have dosage by weight. So the formula for this one is what is the order times the weight in kilograms divided by what you have. Sometimes they'll have by volume, sometimes they won't, but you'll get that in the problem. So for an example, you have prednisone 2.5 milligrams per kg ordered for your patient who weighs 77 pounds. Available is 125 milligrams per 2 mLs. So what you would do 2.5 milligrams times this weight in kilos. So to get 77 pounds to kilos, you want to divide by 2.2, which in this case, it is 35. So here you have 2.5 milligrams times 35 kilograms over 125, and then it has volume. This is your volume right here. So you want to times it by 2 mLs. So now you have 2.5 milligrams times 35 kilograms. Whatever number you get here, you want to divide that by 125 times 2, which then at the very end, you should get 1.4 mLs is what you would give this peds patient. And then that's all I have for my PowerPoint.
Okay, cool. So you may want to ask her if she has any like struggles or questions for you as a ask her if she's there.
Do you guys have any questions at all? You can put them in the chat or you can use the microphone.
So I've heard a lot of people say like desired over have. It's harder to do like the more complex ones, which is why people like to do, what's it called?
Ratio proportion.
Dimensional analysis, maybe.
Dimensional analysis is literally desired over have, but the long way.
Right, yeah. So, and that's what Serva says, like, she prefers dimensional analysis because it's more detailed, I guess. But for me, that would be harder.
Yeah, I think it's harder.
Because there's more things to get wrong,
Mm-hmm.
or there are more steps you're taking that could go wrong. So yeah. I'm gonna ask her.
Dominique.
Do you guys have any questions?
There's a question on the chat.
Okay, I'm gonna do some practice problems on the board. Feel free to try them out.
Oh, Dominique said she uses ratio and proportions,
Okay.
so,
That I do not know how to do.
yeah.
Let's see. I think I'll write down one of the problems and then
Mm-hmm.
let's see. So then I get the master here. So what you want to do for here is you want to get this 2. And the order is 2 milliequivalents per kg. And there's no other volume in this problem. So it's essentially 2 times the weight. And so here you want to convert 50 pounds to kilos, which is 50 divided by 2.2, which is 22.72. So you would times 22.72 times 2, and you should get 45.45. In this problem though, it'll tell you to round to the nearest 100th or 10th. Here, it's to round to the nearest 10th. So then essentially it would just be 45.4.
So the nearest tenth isn't rounded
Yeah,
to the, like, if there's a 5 after it, you don't round it to 5.
you don't
it
round,
would
you just look
yeah,
up the actual number.
Gotcha.
That took me forever to figure out.
Yeah, that's confusing.
And I got these from ATI, so like I did them and then I checked them,
Right.
and if I got them wrong or if I got them right. Okay. So for here is your order. This is what you desire to give your patient. Here is your weight. And here is what you have. So in this problem, I'm going to do 50 milligrams times 32 pounds, which is, let's see, 32 divided by 2.2 over so that's 50 times 14.54 divided by 200 times 5. So you should get 18.175. But with this particular problem, it'll specify divided into equal doses. And then it'll give you the amount of hours that you'll be giving this patient. So when it comes to day, every 6 hours within a 24-hour period, you'll be giving this patient their erythromycin. So if you divide 6 by 24, you'll be giving it 4 times a day. And since it's divided, you want to divide this by 4. You're going to be giving 4 equal doses. Which I believe I got 4.5. Let me double check. Yeah, 4.5.
Looks good.
Oh, you can see it? Okay, cool. It's not a toddler, it's a child. Okay. So once again, here is what you are desiring. So what is your order? And then here is your weight of your patient. And then here is what you have. So essentially 25 milligrams times 43 in kilos. Over 250 times 5. So I got 977 total for the day. But here you are dividing it into a dose every 8 hours. So every 8 hours, how many times does that occur in a day? That is 3. So you're going to divide it by 3 times, which is how often you'll be giving it, which is 3.3. And then zero point eight. So this is a little bit simpler. Even though it says every 6 hours, you're not dividing it. So you don't need to do that trick that I was doing at the very end, where you divide how many times the 6 occur in a 24-hour period and divide that by 4. So in this problem, this right here is considered a distractor. So for here, this is your order, and this is what you have. So essentially you have 120 milligrams divided by 80 milligrams of what you have times 1 ml. So if you ever see, like in a problem where it just has 80 milligrams divided and then like a slash and then just mLs, that's just considered 1. So then essentially it's 120 divided by 80 times 1, which is, I can't do it in my head. Then you'll just be giving 1.5 mLs to this patient. I just have one more. Okay. All right, so one last problem. Okay, so for here, it's the same thing as the other problem. So you have, this is your order. This is what you desire to give your patient is 100 milligrams. And then what you have available is 75 milligrams per 1 ml. Even though this just says ml, it's considered 1. So you have 100 milligrams divided by 75 milligrams times 1. which then you should get 0.5. Make sure. And I think I did this one wrong. Yep, 1.3. Sorry. But there you go. And it's all like that. Yeah.
I'm gonna take over here and just see if she has it. Hello. Do you guys have any questions for Alex while she's here? Any, I don't know, problems that you have, or if, complications you run into when you're doing the dosage calculations?
I don't have any questions, thank you.
Okay. Yeah, you said, I saw you said you do ratio and proportion, so has that worked well for you? Is that something that you're going to continue to do, or were you like curious about desired over have to use in the future? Oh, she can't hear me. Having a hard time. It's probably the mask. Sorry about that. All right. Well, if there are no questions, then I guess we are done here. So thank you, Alex, for putting this together. I'm sure we'll need you in the future as well. So, all right. So we'll see you guys